Hello everyone, this is Emmanuel Sandeep. So today, let's discuss about this topic called tropical cyclones. And before I discuss about in detail with regard to tropical cyclones and all, let me give you a brief introduction with regard to the climatological concepts which are influencing the origination of cyclones and all. Earth as a body is a body which is rotating on its own axis but is rotating on a tilted axis and is also revolving around the sun in an elliptical orbital path. But as it is rotating on a tilted axis and revolving in an elliptical orbital path, the angle of sun's inclination is not vertical or perpendicular all across your Earth's body, and only a few parts of your Earth's body receives vertical sun's inclination. The other parts of the Earth's surface receives angle of sun's inclination which is less than 90 degrees, and of which you're supposed to have a basic understanding as to where your equator is and where your tropics, that is your both Tropic of Cancer and Capricorn, are, where your Arctic Circle and Antarctic Circle, where your North Pole and South Pole and all. So now as you observe this diagram, you get to see that yes, a region between Tropic of Cancer and Capricorn is considered to be a tropical region, and a region beyond Tropic of Cancer and Tropic of Capricorn until the latitudes of 66.5 degree north, which is your Arctic Circle, and 66.5 degree south, Antarctic Circle. This region is considered to be as temperate region, and beyond that regions of 66.5 both north and south, you consider that being a region called polar region. So yes, I mean, when you talk about your temperate region or your polar region, the angle of sun's inclination is not vertical, and the angle of sun's inclination is always lesser than 90 degree angle. So the moment there is a change in the angle of sun's inclination, the amount of energy absorbed by the Earth's surface at the higher latitudes is less, and the Earth's surface, which is close to the equator, where they receive good amount of vertical sun's inclination, you do have higher amount of energy. So the amount of energy absorbed is more. So there is a difference in temperatures. So that's the reason why there is difference in pressure conditions, where you talk about presence of high pressures, low pressures and all. And as we move further, as you observe this diagram, yes, there is a regions of tropics where you have trade winds which are moving from higher pressure to lower pressure. You get to see moving from higher pressure to lower pressures over towards across subpolar, and you get to see this higher pressure of your polar moving towards subpolar lows. So why do air molecules as a wind in a horizontal manner to the Earth's surface move from higher pressure to low pressure? Just because of your pressure differences, and that pressure differences is because of the change in the temperatures. Is it so? Yes. So now as we move further along the Earth's body, we have two different kinds of cyclones. That is, one, we get to see the cyclones across temperate region, and they're called as temperate cyclones or frontal cyclones, and we do see cyclones across tropical region, which have been named as tropical cyclones or tropical, only the tropical cyclones, but they have been named in different manner depending on the type of ocean they have got originated. Now as we move further into this in detail, as we discuss about this tropical cyclones as a topic, let's see as to what we are going to discuss in this origin. We are going to have a very good amount of idea as to why and how the cyclones are being originated, specifically the tropical cyclones, in this video. And then I'm going to talk about the features of tropical cyclones as to how they've been featured, and we'll be discussing about the structure and the characteristics of it. And I'll also be talking about the regional distribution, the environmental importance, and I'll also be talking in context with the present and the recent cyclonic activities also. Yes, let's get into this topic in detail. So I guess you are all excited to know about this topic and have a very good amount of understanding. Good luck. Yeah, let's move into it. Let's get into it. Now, the origin of tropical cyclones. What are the prerequisites? What are the favorable conditions for the origin of tropical cyclones? And as we talk about all those things, let's learn as to what a cyclone is first of all. What is a cyclone? It's a rapidly rotating system characterized by a low pressure center and a low level atmospheric circulation with a spirally arranged clouds with thunderstorms and rainfall across tropical oceans. And only then you call it as a tropical cyclone. How is it being originated? What are the prerequisites for the origination of your tropical cyclones and all? Yes, let's get into it. As we talk about this as a basic understanding, let's learn this few points first, and then I'll be discussing each and every point one after the other. Large and continuous supply of warm and moist air, larger value of Coriolis force, existence of weak tropical disturbances, upper level outflow, weak vertical wind shear, small atmospheric vortices in the intertropical convergence zone. Now let's learn about each and every point in detail as we move further. See, across your oceans, that specifically within your tropics, the temperature of the waters are very much normal, wherein they have been maintained somewhere between 21 degrees to 24 degrees on an average. That will be your temperature of your oceans. But across few regions of the oceans, if at all, if there is any rise in the temperature of waters, now you get to see a change in the weather phenomena. So now, if at all along the ocean surface, if the temperature is rising about 27 degrees Celsius, now you call it as higher temperatures across that region. So the moment there is higher temperatures, I should see good amount of low pressure prevailing over there. And the moment we have a low pressure, what do I see? I see good amount of convergence of warm and moist air. Why? The moment I see this increase in temperatures, I get to see good amount of evaporation of the waters, and I get to see good amount of moist air within that specified regions. And that warm and moist air are trying to converge. Why? The moment there is a low pressure, always air molecule move from a higher temperature region, from a higher pressure region to a lower pressure region. A region which has got a lower temperature will be having a higher pressure. A region which has got a higher temperature has got a lower pressure. So now air molecules, let's say that this is your low pressure, and this air molecules as wind, if this is the regions of higher temperature and higher pressures, now air molecule move from this higher pressure to lower pressures, and they tend to move. As they are moving, they are also carrying good amount of warm and moist air. So as they are carrying good amount of moist air into this, so let's learn as to what is happening also. So there is a large and continuous supply of warm and moist air. Larger value of Coriolis force. What is this Coriolis force? It's a deflective force, a pseudo force, which is trying to deflect wind which are moving from higher pressure to lower pressures, because this is a force which is which is against the rotatory motion of the earth. Earth as a body is rotating from west to east, and in opposite direction there is a force which is a pseudo force which cannot be observed or which cannot be seen with the naked eye, which is calling it as Coriolis force. And there should be a good amount of Coriolis force. Where do we see good amount of Coriolis force? Do we find good amount of Coriolis force across close to the equatorial region? No. So now anything above the latitudes of 5 degrees 220 degrees north and south, I get to see this presence of low pressures and convergence of air with good amount of Coriolis force. But if I'm much closer to equator, that is anything between 0 to 5, I'm not going to observe good amount of Coriolis force. The amount of Coriolis force is weaker, and I cannot say that there is a chance for the origination of cyclonic activities and all. Now, I mean, if you want to have a better understanding as to how this Coriolis force and all appears, this is a diagram where it shows saying that yes, this is the center where air molecules are trying to converge, but this air molecules from higher pressure region to lower pressure region, they're trying to converge. As they're trying to converge, but they have been deflected. They're moving in this direction, but they're not moving in this direction. They've been deflected, and they had been deflected because of the force called the Coriolis force. They want to move inside this because of the lowest pressure over here, which is called where there is a force called pressure gradient force. In spite of the presence of pressure gradient force, as there is a good amount of Coriolis force which is much stronger, now that's trying to get deflected, and then it enters into your low pressure zones within a deflected path, and this leads to spiraling of your wind moment. I mean, the presence of Coriolis force, which we have discussed, is allowing to have a spiraling nature of your wind moment towards your low pressure system. And then moving further, the existence of weak tropical disturbances. What does it mean? Within your tropical region, you are not supposed to have a large amount of tropical disturbances, and that if you have a large amount of tropical disturbances across that specified regions, the origination of cyclonic activity or the cyclonic event gets reduced, because the amount of wind which is supposed to come, or the amount of forces which are supposed to occur across that region, reduces, because there are other disturbances which are occurring. So it may not help in good amount of strengthening of this low pressure system into a cyclone. So there should be a very weak tropical disturbances. And then the upper level outflow, I'll talk about it as I move further. And then let's discuss about this weak vertical wind shear. What is this weak vertical wind shear? See, as we talk about this slide, I'll just show you the vertical wind shear. Yes, see this diagram wherein you're trying, there is a spiraling of your air molecule as a wind over here. There is spiraling, and later on, the moment there is a low pressure, there is higher temperatures, because of which the air molecules updrafts. That's a very common phenomena, because the air molecule starts expanding. But during this process of expansion of your air molecules, which are warm and moist air, there shouldn't be any amount of vertical wind shear. What is this? The air molecules should not move downwards. There should not be there should be a very less amount of downdraft. If at all, if there is a wind shear like this, yes, the updraftment of air molecules gets obstructed, and the proper origination of the cyclonic event also gets disturbed. So we are supposed to have a better understanding, saying that yes, we should have a very weak vertical wind shear. And then later on, during this origination of a cyclonic activity, it is also looking for good amount of atmospheric vortices, small atmospheric vortices. What are they? Air molecules starts whirling within the atmosphere, and this whirling of air molecules is nothing, gives you small vortices, a funnel shaped features across your air mass, and these are your atmospheric vortices. and these are the ones which are majorly seen along close to the regions of intertropical convergence zones. What are these intertropical convergence zones? A zone where the trade winds, both from your northern hemisphere as well as the southern hemisphere, try to approach into each other, and this regions where they're trying to meet each other is considered to be as intertropical convergence zone. And this convergence, across this convergence zone, close to this convergence zone, we are supposed to observe small vortices for the origination of tropical cyclone. Now moving further, in this present context, let's talk about this cyclonic event which is now occurring called Amphan. What is happening? During this period of time, the intertropical convergence zone is not across your equator, and it has moved towards north, and it is somewhere between the latitudes of 14 to 18 degrees north and all, somewhere between 10 and 18. So it's above the equator. So if your intertropical convergence zone is somewhere over here, now as per our earlier point what we have discussed, we are supposed to see good amount of small vortices within the atmosphere, and these smaller vortices help in strengthening of a cyclone. And the moment we have the small vortices, that shows that yes, we got a chance for the origination of cyclonic event. Why do we see this origination of vortices over here? Let's see, because I mean, if you have an ITCZ over here, air molecules from southern hemisphere crossing this equator and is now entering into this ITC, I mean coming closer to ITCZ, and there is also winds which are coming from higher latitudes, that is from your subtropical high pressures of northern hemisphere moving towards ITCZ, and as they're trying to converge into each other. Are they of similar in temperatures? I mean, whether the air masses are similar? No. There is slight amount of dissimilarity in the temperatures of the air masses which have been carried from the northern hemisphere as well as southern hemispheres. Because from northern hemisphere they're moving from your land mass, but from southern hemisphere they're moving from water body. So the amount of temperature has been differing. So the moment there is a change in the temperatures, yes, you get to see this origination of vortices within your atmosphere. And with the help of this vortices, if at all during this period of time when your sun's insolation is almost vertical along this regions of your Indian landmass and all, along those latitudes of 14, 10 and 14, now the Bay of Bengal waters or Arabian waters are been warmed up immensely, and across a specific region where you see good amount of vortices, as well as if you are seeing the temperature of the waters being higher than 27 degrees Celsius, if they are increased about 27 degrees Celsius, now you get to see a chance for that being changing itself into a depression initially, which is nothing but the tropical cyclogenesis. A tropical depression now originates. 27 degrees of Celsius of rise in temperature and good amount of vortices in the atmosphere helps you to get to see this origination of depressions. And now the moment that depressions are there is also, I mean, it also looks for a good amount of Coriolis force. And the moment there is a good amount of Coriolis force, and apart from that, within that specified regions, anywhere close by, you should not see any amount of tropical disturbances. Now, air molecule try to converge into this low pressure system at a much faster pace with a good amount of deflective activity, and they converge in a deflected path. And as they're trying to converge, they're carrying good amount of warm and moist air. And this regions of low pressure is now getting intensified and is also been strengthened by the arrival of good amount of moist laden winds into that low pressures, which are warm, which are stronger in nature, and now this pressure system intensifies itself and lowers the pressures much below your normal low pressures which are prevailing over there. And if you properly observe the present news and all, it says that yes, we have almost 936 millibars of your pressures over there along the along the low pressure system of Amphen and all. These are your isobars where the air molecules are trying to converge into this low pressure system. That's how you get to see this diagram. Yes, the air molecules are trying to converge into this. So what is happening now? The moment the air molecules are trying to converge, the air molecules, after they're getting converged, they're getting much closer to the low pressure system. They've been completely warm, they are moist, and now these warm air molecules start expanding, and they are trying to get updrafted into the upper layers of your atmosphere. As they're getting updrafted into the upper layers of your atmosphere, what happens then? These water vapor molecules, moving into higher altitudes, condenses to form into a water droplets, good amount of clouds and all. So now these clouds have been forming across the regions. The moment there is good amount of winds which are entering into this low pressure system, there is a large amount of clouds which are also been forming. And now moving further, this depression, if at all, if the amount of speed of the winds are have been seen above 40 kilometers, if there is a increase in the speed of the winds within the close to the regions of low pressure system which are above 40 kilometers, now you consider it being as a tropical cyclone. So a depression with a minimum amount of prerequisites like higher temperature of waters, with proper amount of vortices, and good amount of Coriolis force and weak tropical disturbances, then this depression with the greater amount of winds trying to converge with a faster movement of winds into the low pressure system, if they are above 40 kilometers of its speeds, now it is now considered to be changing itself into a tropical cyclone. Now we have a tropical cyclone which have been originated, where, as I told you, the tropical cyclones are the one which are majorly seen between the latitudes of 5 and 20 degrees north and south latitudes. And specifically, this is your strongest area, 10 to 15 degrees, both north and south, within your Indian oceans, not across all your oceans, but specifically with regard to 10 to 15 degrees north is your most effective regions where you get to see good amount of origination of tropical cyclones and all. Now moving further, as we observe into this slides, yes, I guess I've done with this. Large and continuous supply of warm moist air, larger value of Coriolis force, existence of weak tropical disturbances. Then I didn't do it. Upper level outflow. So what is this? So the moment there is good amount of air molecules which are getting updrafted, it also says that along your higher altitudes of your troposphere, there should be a good amount of divergence of air molecules. Whatever the air molecules which are carrying good amount of moisture into the higher altitudes, condensing to form into good amount of clouds. But the air molecules which have been cooler now updrafts further, and they should diverge. If at all, if they're not diverging, if they're trying to settle or if they're trying to downdraft, now the strengthening of this low pressure system into a cyclone ceases. It cannot be strengthened because there is no chance for the air molecules to get updrafted because there is some force which is exerting from your higher altitudes. So at your higher altitudes, there should be a good amount of divergence, and that's what it says, that yes, in the upper levels there should be good amount of outflow of air. So only then this tropical cyclones gets originated. So by this, what do we see? We get to see a very good structure which has been formed, which is similar like this. Now, as we observe the sea, you got to see this warmer temperatures being warmed up, winds getting stronger towards the low pressure system, And this low pressure system, which is encircled, which is specified with good amount of isobaric points, and now this is considered to be as low pressure, and this region is considered to be as eye of the cyclone. And to this eye of the cyclone and to this isobaric lines, you have numerous isobaric lines which have been surrounding this, but the central point is your eye of your cyclone. And to this, towards this eye, all your air molecules are trying to converge. But are they meeting each other? No. The moment they are coming closer to the eye wall, this is your eye wall. The central part is your eye, and the margins is your eye wall. The moment they are trying to approach towards your eye wall, they've been completely warmed up, and they're getting updrafted. And as they're getting updrafted, they're not moving in a vertical manner. They're just spiraling along that eye wall and getting updrafted. And this updraftment leads to formation of good amount of clouds. And very much close to the eye wall, you get to see a very tall, towering clouds which are thick enough, which have been named as cumulonimbus clouds. And as we observe each and every isobaric lines, depending on it, we also see spiral arrangement of clouds. I get to see one rain band over here, another rain band over here, another rain band over here, but of different heights. Why? Difference in pressure, difference in temperatures. So if there is a difference in temperature, there is a difference in updraftment also. So where do you have higher temperatures? Very much close to the eye. So higher temperatures over there, higher the updraftment. So that's the reason why I get to see a very thick wall of clouds, calling it as cumulonimbus clouds. And as well, we also see good amount of outflow of air molecules, and which is across your higher altitudes, which is where your presence of high pressures across higher altitudes. And only when you have a proper high pressure system across higher altitudes, that is at higher positions of your eye, then you can see a good amount of convergence of air close to the ocean surface, where you have this low pressure. If you want to see good amount of convergence of air, you should have proper matured high pressure system where there is proper amount of outflow also. And warm moisture is drawn into the center. Winds get stronger towards the eye and eye wall, and I get to see good amount of clouds forming across that region, and they have been extended almost until the heights of 12,000 to 15,000 meters as well. And the thick amount of clouds have been forming. And then moving further into the topics, yes. See, as we properly observe this entire cyclonic event, they're just spiraling. The warm air spirals up quickly. And this spiraling is because of the presence of Coriolis force, isn't it? Yes. And it also says the upper atmosphere should have good amount of high pressure dispersing rising air. Whatever the air which is rising should get dispersed, and the water vapor which is present, which has been carried into the higher altitudes, should form into good amount of clouds. And then moving further, into this topic, this is your basic diagram which shows as to how a cyclone or an initial atmospheric vortices or small disturbances leading to formation into a proper cyclone. See, this is your trade winds which are coming, and there are some winds which these are other winds which are trying to converge over here. So because of the convergence or because of this presence of winds, there is a good amount of tropical disturbances where there is small amount of vortices which have been originating, and this leading to formation into a small depression, and that depression with a proper eye, with a predefined eye from the surface of the ocean to the higher altitudes or the upper layers of your troposphere. If there is a proper structure of eye which has been built and which has got a higher amount of winds with a greater amount of speeds of winds trying to converge across the surface of the ocean into the low pressure system, which are above 40 kilometers of speeds, now you consider that being into a tropical cyclone. Now this tropical cyclone, it further moves into the higher, other regions also. But let's learn about as to how it is moving and all as we move further. I'll come back again into this area, but let's learn about this. What are the features of tropical cyclone? So we are very clear about as to what your tropical cyclones and all are and how they originate. And features. Where do we find this? Found at certain seasons in well-defined areas of the tropics. Why do it say that at certain seasons? Yes. Within the tropical region, only when there is proper warming up of the oceans, there is a good chance for the origination of tropical cyclones. And if you don't have a good amount of warming up of the oceans, you are not going to see the origination of tropical cyclones and all. And they form only over oceans having high surface temperatures. So if you want to see high surface temperatures, what should you see? You should see a good amount of sun sensation, which is almost vertical. So only in a specific season I get to see vertical sun sensations. And they do not have fronts. What are fronts? A region where convergence of two different air masses, cold air and warm air. If that is a point, which is seen across your temperate latitudes, and this is not seen across your tropical latitudes, and that should not have any frontal formation. More intense than extratropical cyclones. Yes, these are the extratropical cyclones which are above your tropical latitudes. If they are moving into, if they are seen across temperate region, they are considered to be as extratropical cyclones. And the intensity of your tropical cyclones are very high in comparison to extratropical cyclones, and they exist only on oceans. They have central core of calm or light winds, and they derive their energy from the latent heat of condensation. What is this latent heat of condensation? The water molecules have been warmed up, changing itself into gaseous molecules, and these gaseous molecules getting updrafted, and just because of heat which has been generated along the water body, that has been changed into a gaseous molecule and is getting updrafted. These gaseous molecules later on, as they're getting updrafted, condenses again to form into clouds. So they derive their energy from the latent heat of condensation, and this latent heat of condensation should be maximum. Only then, yes, I get to see thick clouds, and just because of your good amount of stronger winds, I get to see good amount of convergence and warm and moist airs. And only when you have stronger winds, I get to see this convergence of warm and moist airs. And this updraftment is also dependent on higher amount of temperatures. The more the heat absorbed, the more the elevated, the more the updraftment of your air molecule. And the more the updraftment, thicker the cloud, and the amount of condensation is also in a larger volumes. So they derive their energy from the latent heat of condensation. And they have a central core of calm or light winds. So what is this calm and light winds? As we observe this, within the center, or let's look into this diagram. Within the center, I'm not going to, that is within the eye, you're not going to see movement of air molecules, whether it be in a vertical manner or in a horizontal manner, and that is very calm, clear. Where if you observe this eye from top of your Earth's body, or in a satellite images, you'll be seeing a clear cut, very much conspicuous eye which doesn't have a cloud and all. It's very clear. The eye should be very clear. Yeah, it's something like this. The eye is very clear over here. So there is no cloud formations because there is no vertical updraftment of air molecules nor horizontal movement of air molecules, and there is calm. So the calm or light winds are there, and the central core is very calm. What is the central core? The eye. And then sorry, yeah. What are the other features as we talk about the structures of your wind and all, structures of your tropical cyclones and all? As we talk about the structures of your tropical cyclones and all, it says that yes, this is the one which has got eye wall. It also got good amount of diameter. The eye has got a diameter which is diameter for about 20 to 40 kilometers of diameter. At times it ranges until 100 kilometers also. So these are all your parts of your structure of your tropical cyclones and all. And it got good amount of rain bands. So these are all your different structures of your tropical cyclone. And then moving further into this topic, the tropical cyclones which have been originating, they are not static, they're moving, and they have been supplied with good amount of warmth and moisture, and of which in your northern hemisphere they are encircling in anti-clockwise manner, and in southern hemisphere they are rotating in clockwise manner. So one is an anti-clockwise, the other one is clockwise. It's all because of your Coriolis force, because in your northern hemisphere, let's say now this is your eye, if this is your isobars, because of your Coriolis force they should deflect towards right. So deflected towards right and then entering into it, deflected towards right and then entering into the low pressure system, and this is an anti-clockwise manner. And if you talk about in the southern hemisphere, yes, you have an eye, got an eye wall. And what is the direction of your in southern hemisphere? The deflection of your winds is in a leftward manner. So I get to see left. So I was supposed to see this wind moving in this direction, but they've been deflected towards left and then converging, left and converging. So I get to see clockwise presence of cyclonic movement within your southern hemisphere, and we see anti-clockwise movement of cyclonic activities in northern hemisphere. And then moving further, yeah, these cyclones which are present, which have been originated within the oceans, that is within your tropical oceans, they always move from east to west. They're moving from always from east to west, and this movement of tropical cyclonic event from east to west is because of one, the wind system, two, the ocean currents which are trying to influence these movements, and three, the divergence or the air aloft, which is along your topmost portions of your higher altitudes, the divergent regions, where this divergent of your air molecules across your upper troposphere of your eye, within your eye across your upper troposphere, that is one of the major one which is also trying to drift this cyclone. And if you properly observe, if we want to study about the present day or the recent cyclonic events, the amphan which is present, the high pressure system which is present across your upper troposphere has got a bent towards Myanmar and Bangladesh. And that was the reason why the meteorologist says that even though your low pressure system is close to the regions of Odisha and all, they says that yes, because of the bent of your air aloft, there is a greater amount of chances that this tropical cyclone or this entire low pressure system which is present will shift itself to north and northeastwards, because the air aloft has already got a bend towards Bangladesh and Myanmar, that is towards north and northeast. So yes, the winds, the planetary winds, the ocean currents and the air aloft are determining the movement of tropical cyclones. But normally they are supposed to move from east to west. And as we observe into this earlier diagrams, yes, they're moving from east to west, but they're also been drifted towards north. And across few regions, yes, the drifting is much further, and they've drifted further because of your wind systems and all, and they're entering into higher latitudes and changing themselves into extratropical cyclones. These are into extratropical cyclones. So earlier it was a tropical cyclone. If at all, if there is a chance of water body much further into higher latitudes, yes, it recurves or it enters into, moving towards north and northeastwards and changes itself into a extratropical cyclones also. So that's a very common phenomenon, not across your Bay of Bengal or nor your Arabian Sea, because your Arabian waters as well as your Bay of Bengal waters have been restricted within the latitudes of 20 and 22. Beyond that, you don't have these water bodies. But talk about your Atlantic or talk about your Pacific, yes, you got a very fair chances where the cyclones which have been originated within your tropical region, have got a fair chances. If at all, if that is not meeting up any land, or because of your wind systems, or because of your air aloft, or because of your currents, they gets drifted and they also change itself into an extratropical cyclones also. Now moving further into the topic, this is a diagram where you talk about, you get to see this Hurricane Dorian, which is to the east of North American continent, which have been originated close to the regions of Florida, but have been drifted towards north, almost parallel to the east coast of North America, and which have been originated somewhere between the latitudes of 25 and all, but moving towards north and entering close, moving towards 40° north. And this is the one which is Florence, originated somewhere around 20 and 25, but moved again towards east to west. But as they're moving towards west, they've been slightly got drifted because of your presence of wind systems, or because of the presence of air aloft and all, and the currents which are present over there, and they've drifted towards north and northwestwards, northwest region. Initially towards west and then to northwest. So the drifting happens. So what we are supposed to remember is, yes, always a tropical cyclone move in a direction from east to west and then to north, and this movement from east to west and then to north is dependent on the wind systems prevailing across that region and the ocean currents prevailing across that region, as well as the air aloft that is across your higher altitudes, the air aloft where your divergence of your air molecules within the eye happening, and that is also playing a major role in defining the path of your tropical cyclone. Now moving further, last before that, as we trying to end this topic, a tropical depression changing itself into a tropical cyclone, and this tropical cyclone drifts east to west. As they're moving from east to west, if at all, if there is any land which is trying to obstruct it, now and try to hit onto the land, and the moment this cyclonic activity, the low pressure system and all, is trying to enter onto the land or trying to enter onto the coastline, now that's a phenomena called landfall. The moment we have a landfall, what happens? Anyway, the moment we have a good amount of tropical cyclone over there, you got to see good amount of clouds, thick clouds, which are cumulonimbus clouds, giving you heavy amount of rainfall, as well as you have good amount of wind speeds and all. But the moment it is coming closer to your coastline, if this eye of the cyclone is coming closer to this closer to the coastline, the amount of wind speeds across your coast increases. And because of the high amount of wind speeds which are prevailing, there is good amount of destruction. Destruction in a manner where you get to see fall of trees, electric poles, telephone poles, the telephone lines and all getting destructed. And apart from that, apart from your higher speeds of winds, now there is also one more phenomena where the waters across your oceans rises above the normal mean sea level, and because of high amount of wave actions enters into your habitations. Why? Based on your earlier understanding, we said that yes, waters are with higher temperatures. The moment there is a higher temperatures, water also expands. And now the water level, which is supposed to be, if this is your mean sea level, no. Whenever you get to see an eye of a cyclone over there, and you get to see higher temperatures, and I see a rise in the level of sea waters. And there is a rise in sea level, level of the sea waters, as well as there is good amount of winds which are prevailing across that region. So because of the winds, I get to see turbulences, and I get to see crust center forming into good amount of waves. And this rise in sea level and this good amount of wave action makes this waters enter into the nearby habitations. And if at all, during this landfall, I mean, this is called the surge in the water. This is called storm surge. During the storm surge or during this landfall time, if at all, if that is a region which is having any phenomena which is almost something like your spring tide, I mean, this is your astronomical tides and all. If at all, if you have a spring tide across that region, the amount of rise in the sea level is much further beyond the normal tide levels, and there is large amount of regions which is getting submerged, and there is huge amount of submergence which devastates the entire livelihood across the regions. Yes, you get to see this diagram, the submergence of your entire land. I mean, the waves are entering into your habitations. And now, apart from this, there is also thick amount of cloud, which are cumulonimbus clouds. You get to see heavy amount of rainfall. The entire region is getting flooded. I mean, there is riverine floods, there is coastal flooding because there is storm surge, there is heavy amount of rainfall inundating the entire regions. There is good amount of wind speeds which are trying to disturb the entire activities which is disastrous in nature, isn't it? Yes. And then on, I mean, there's high wind speeds and all inundating the entire land masses. And then moving further, these tropical cyclones which are present, these are the ones which have been distributed within your tropical oceans, not across your tropical lands, but within your tropical oceans. They have been seen across tropical North Atlantic region, across these regions of tropical North Atlantic regions. They're also observed across western, I mean, specifically across the regions of Caribbean islands, the Cuba regions and all. And they're also seen across the western parts of tropical North Pacific, western part of tropical North Pacific, across these regions, Philippines and all across these regions of Fiji Islands and all. And then these are also observed across eastern parts of tropical North Pacific, across this region, the western parts of Mexico and the Central American countries. So across these regions, and these are the tropical cyclones which have also been observed across the Bay of Bengal waters as well as the Arabian Sea waters, and they're also seen across the South Indian Ocean, across these regions as well, across these regions. So these are all the regions where you get to see a good amount of tropical cyclones which have been distributed from one region. But the amount of tropical cyclones towards the southern parts of Atlantic is very minimal, because there is large weights of water body and the amount of temperature difference are very minimal, and you don't see any ITCZ which is shifting towards lower to the equatorial latitudes. Shift is very minimal. So because of all these phenomena, you will not see a good amount of cyclonic events which are occurring across this coast of Brazil or something and all. So they're mainly observed across your northern part of Atlantic tropical regions, northern part of Atlantic regions. And lastly, yes, do they die out? Yes, they do die out. The tropical cyclones which have been formed because of different factors which we have discussed, like presence of vortices, atmospheric vortices, the presence of warm moist air, the presence of good amount of Coriolis force, and the weak tropical disturbances within that regions, and which led to this origination of tropical cyclones. But this tropical cyclones, after the landfall, after they getting onto the land, as they're moving onto the land, because of the frictional force, slowly reduces in its speed. The wind speeds reduces as well. There is no input of good amount of warm moisture because onto land, and because that's onto land. So at some point of time, they just die down. So movement of the over the land, they will die down because there is no supply of warm moisture, and because of the frictional force on the earth's surface, tropical cyclone decays. As well, the movement over cold waters. Yes, the moment there is colder waters, now there is no supply of moist air. You don't have evaporation, and you don't see good amount of moisture which have been supplied, and it again decays. And the movement into the region with higher wind shear and dry atmosphere. Yes, as I told you that the downdraft, the wind shear which is present, the vertical wind shear should be very minimal. If at all, if you have a higher wind shear, yeah, you don't see good amount of tropical cyclones which have been originated. If at all, if this tropical cyclone which have been originated, if that is moving into a region with higher wind shear, where do you see this higher wind shear? Across regions of higher pressure regions, subtropical high pressures. Wherever you find higher pressure regions, you get to see good amount of wind shear, the vertical wind shear, because along your upper troposphere, air molecules converge and downdrafts or descends, and this is your vertical wind shear. So this vertical wind shear, if it is higher in capacity, it will not allow the tropical cyclone or the cyclonic event to strengthen. That show, the moment you have a high wind shear or higher wind downdraft, you should have also get to have the dry atmosphere across that region. It's not moist. So because of all these conditions, the tropical cyclones decays across different regions. But the moment they're originating, and they last until the landfall. But it does not mean the moment the landfall has happened, it immediately dies down. It takes almost a week time to die down completely, because the moment the eye of the cyclone is passing through that region very much close to the coastline, you must see heavy amount of wind speeds, high amount of rainfall, and that gives you a large amount of destruction of your trees falling and all. But you get to see heavy amount of rainfall, which leads to flooding of the regions. And apart from that, because of the storm surge, again a flooding. Because of this, the event which has been, even though if it is entering into the land, the amount of disaster, the periodicity of the disaster furthermore, that stays for about a week or more. So that's about your tropical cyclone, a major phenomena which is seen within your tropical latitudes. That's all for now. Thank you. If you like this, please do share this and enjoy. And I'll do more of this kind of videos a lot. Thank you. Bye-bye.